We saw how we can set up a very simple recursive function, and the function does call itself, but then it doesn't do much useful work, mainly because it just goes right into infinite recursion. That is, it calls itself and eventually it runs out of space and then crashes. So it only does part of what only satisfies some of the conditions that we need to have useful recursive functions. So let me just go back and remind you the essential components of recursive functions are: one, the function calls itself, and so there we succeeded. We did have a function f that calls itself, and we saw that this actually does work, but then what's wrong with doing this is that it doesn't actually do anything useful. And the way you can get things to get a recursive function to do something useful is, one, basically you want the recursion to stop. You should work on some input problem size, and that input problem size should get smaller every time the function calls itself. And we saw that the function does call itself. We use the debugger, and that's usually the way you want to check things out when you're debugging recursive functions. And then finally, the input should get so small that there should be a base case. That is, you check this case and you can solve the problem of this size so simply that by, let's say, just a couple of statements, or by calling a separate function, you can stop the recursion. And then what should happen is all of the recursive function calls should sort of come off the stack, and they should eventually return to whatever call the recursive function. So when recursion does work, you have a function that calls itself, but somehow it's able to stop, and then eventually it should come back here. What happened in this simple recursive function is that it calls itself so many times, it ran out of stack space and crashed. So we don't want to do that. So now let's take a second look at that max function that we set up a few slides ago. And I will show you, just to show you that the same things still do happen. That is, you see stuff on the stack. So you should see this kind of picture. So keep this picture in mind. You'll have main call max, and then it should return from max to main, and you'll see how a successful return happens. So when you return from here, it should go back here, and then you call max again. Let me just show you what the code looks like. We had this kind of thing. We had x, y. We call max, and then store that output of max, and then you call max again. Okay, so we want to see max return twice from being called. So let's just take a quick look at that, and then we'll move on to more recursive functions. Okay, so here it is. Nice simple function call with two parameters, int a and int b. If a is greater than b, return a, else return b. Alright, and so this is not recursive. We're just going to see how functions should behave. Even if they're recursive, they should return to wherever they were called from. Oops, I need a semicolon. And I can't do this. I have to rename this a is equal to max of x and z. Doesn't matter, I guess. Let's save it and compile it. And let's debug. Okay, switch to debug perspective. And here we are. C++ programs should always stop at the first line, so it's kind of hard to see, but there is a blue arrow here. Alright, so what you want to do is step over this one. That's fine. Step over this, and you can see that x is 5, y is 7, and now we're going to call the max function. We do a step into, and you should be able to step either into or step over, doesn't matter right now. Here A was 5, B is 7, so it's going to hopefully return the 7. So now watch this. This is how functions should work. Even recursive functions should eventually, they should return, oops, back to main. Here it is, it's returned back to main, and now we're at the next line. And so Z is the max of 5 and 7, which is 7. It might be a little hard to see this, but I hope you can see that Z is 7. Now, what we should be able to do is step back into that same function that we called earlier and step through this, return. See, A is 7, B is 5, it should return A. Alright, and when we step over that, it eventually goes to the last statement, and it gives us that something saying that it couldn't figure out how the disassembly worked. So there's no big deal. You can, if you want to put print statements, that'll actually work out better. But hopefully what you saw was that eventually all of this works. You call a function, most of the time it does return. The only time you have to worry really is if you have a recursive function and you're not sure if you did it right. Then what could go wrong is that you might have infinite recursion. That's what could go wrong, and in those cases you have to debug. So let me switch back to the C++ perspective and run this. Oops. Okay, there it is. So it does actually work. You call the function, you call this max function twice, and you saw how things work on the stack. Let's see if you didn't. Let's take another quick look again, because I didn't point it out to you, but let me see if I can. So here, now take a look at the stack. We ran through this once, but here we're going to step through it again. Here's main on the stack, and I just want to point out the picture you want in your mind is this one. That is, if you have this program, you have main, and then you call max, and you should see a thing for max. It's called a stack activation frame, or you can also refer to as like this box that goes on the stack. So where is that? Let's see if you can pull that up. So we set X, we set Y, and here I'm going to step into max. Watch this stack over here. There it is, it goes on the stack. You step through the lines of this, and when you return, it comes off the stack. You call max again, there it goes on the stack. Step through this, and the whole time you still have the box, and now you're going to return. When you return, that box for max goes away, and you're back in main. Okay, it works the same way for recursive functions, at least this putting things on the stack for each function call. That part works the same way for recursive or non-recursive functions. That's just a general technique that's used in just about any programming language that runs on modern CPUs will have a stack. Okay, so I'm hoping, if that's not clear, let me know. Definitely ask questions. The main idea you want to get is that every time you call a function, and it doesn't mean that if you have one function you'll only have one thing on the stack. No, if you have a recursive function, you call it, each time you call the function you get something on the stack. And that's why if you have a situation with infinite recursion, eventually you'll run out of space on the stack and the program crashes. Now let's do something a little bit more useful. So the general approach that we will use is that for this week, we're just going to solve problems that we could actually just as well solve using iteration, that is with loops, but we're just getting our feet wet. We're just learning how to do recursion, and so we will set up recursive programs that we could just as well have used iteration for. Okay, so this is going to be a simple function that what it should do is it should add, given some value n, it should add up all the numbers from 1 to n. Actually, it actually does 0 too, but adding 0 doesn't do anything in this case. It just so happens it's pretty harmless. So we want to find the sum from 1 to n given any n. And the way we do this, watch this. If you look at this, if you look closely at this function, what you will notice maybe is that 1, this function calls itself. So this function is add, calls itself. 2, the thing that it's calling itself with, that is the problem size, is getting smaller. So you call it with n, and it calls itself with n minus 1. So that means here you call itself with, now this new n is actually the old n minus 1, and it calls itself with n minus 1, so that's the old n minus 2, and so on. I know it's a little hard to maybe wrap your heads around, but if this is the first time you've seen recursion, it is kind of hard to deal with, but I think eventually you'll get the hang of it. And the third thing, finally, is an if statement, a simple if statement with a return. So if some condition is met, and that is basically saying if this problem is small enough to solve, I'll solve it right here. The sum from 0 to 0 is just 0. There it is, I've solved your problem. And you might look at this and say, well, where is all the work happening? It turns out the work is all happening right here in this statement. But it turns out this statement is extremely complex just because we use recursion. So in effect, what you're doing is you're saying n plus the sum from 1 to n minus 1, which is n minus 1 plus the sum from n to n, from 1 to n minus 2, and so on. So it turns out this is where you do most of the work. All of this stuff you use for checking. Okay, so in the next video I will show you how this works, how this simple function works. But the basic idea is that you use recursion and you use it the proper way, which is the function calls itself, definitely you need that. Problem gets smaller. You had a problem size n, now you're calling the same function with a smaller problem, n minus 1. And then finally you want to check. If n is small enough, or if the problem is small enough, you have the base case in which the answer is just right here. And this one is a particularly simple one. It might not always be this simple. You might have to maybe call another function that does everything in one step or something like that. Okay, so next video I'll show you how to run this.